Hi, good evening. For today's video, we're going to discuss all about statistics. So this is the introduction part of the statistics. Okay, so let's proceed. So before anything else, let's define first what is statistics. So statistics is the discipline that concerns the collection, organization, analysis, interpretation, and uh, presentation of data. So we have branches of statistics. First one is the descriptive statistics. So in descriptive statistics, it is a method concerning with collecting, describing, and analyzing a set of data without drawing conclusions about a large group. So we have descriptive, and the second one is we have the inferential statistics. So in inferential statistics, it is a branch of statistics concerned with the analysis of a subset of data leading to predictions or inferences about the entire set of data. So more on interpretation of data. So we have also here the frequency distribution. So frequency distribution is a tabular arrangement of data into appropriate categories showing the number of observations in each category or group. So we have two major advantages of a frequency distribution. We have here it encompasses the size of the table, and it makes the data more interpretative. So we have different parts of the frequency table. The first one is the class limit. So it is the groupings or categories defined by the lower and upper limits. So you can see in the given example, samples of the lower and the upper limits. So for class limits, we have lower class limit. So a lower class limit represents the smaller or the smallest number in each group, while the upper class limit, it represents the highest number in each group. Next we have the class size. So it is the width of each interval. For example, in the given lower limits and upper limits, so from 10 to 14, so the class size in this distribution is 5. So you're going to subtract the upper limit to the lower limit, then add plus 1 or add 1. So that will be your class size. So we have also here the class boundaries. So they are the numbers used to separate each category in the frequency distribution, but without gaps created by the class limits. So let's see if we have an example here. Okay, so given examples of lower limits and upper limits. So lower boundary, let's say here from 10 to 14. To get the lower boundary of 10, you just have to subtract it by 0.5. To get the upper boundary of 14, you just have to add 0.5 to 14 or to the upper limit. Okay, so I'll repeat. To get the lower boundary, you just have to subtract 0.5 from the lower limit, and to get the upper boundary, you have to add 0.5 to the upper limit. So class marks. So they are the midpoint of the lower and upper class limits. So as you can see here, the lower limit and the upper limit. So from, let's say, from 10 to 14. And your class mark is represented by x sub m or xm. So to get the class mark, you just have to average or add the lower limit and the upper limit, then divide it by 2. Okay, so let's have another example, 15 to 19. So to get its class mark, you just have to add 15 and 19 and divide it by 2 to get 17. So if you're going to construct a frequency distribution table or frequency distribution, here are some steps we need to consider. First, we need to compute for the value of range. Okay, so range is defined as the difference of the highest score and the lowest score. So it is determined by the formula range, which is equal to the highest score minus the lowest score. So if we're going to determine the class size, so the class size that we computed a while ago was just an easy part. Now, so to determine the class size, we have to use this formula. Class size I, which is equal to range, over the desired number of classes, which is equal to k. So class size is defined by the formula R over k, where k is the desired number of classes. So range as defined by the formula highest score minus the lowest score. So to get the k, or the desired number of classes, we have to use this formula, 1 plus 3.3 logarithm of the n, where n is the total number of frequency or the total number of classes. So another step in constructing frequency distribution, we have to set up the class limits of each class or category. It's up to you if you need to set. It's up to you if you're going to determine what will be the lowest number and the highest number for each category. Set up the class boundaries if needed. So we have to tally the scores in the appropriate classes. And for last part, so if you find the other parts if necessary. So this will be discussed in the previous topics in the future. Okay, so this is an example of a frequency distribution table. So as you can see, given the class interval, the frequency, the class boundaries, and the mid-class. So the mid-class is also known as the class mark. Okay, so that's another term for class mark. Okay. So let's discuss different graphical representation of scores in the frequency distribution table. So first thing is the histogram. Okay, so a histogram is a graphical display of data using bars of different heights. In a histogram, each bar groups numbers into ranges. So taller bars show that more data falls in that range. Excuse me. A histogram also displays the shape and the spread of continuous sample data. So I think we have an example of a histogram. Okay, this is an example of a histogram where the x-axis represent the age, and the y-axis represents the frequency. Kindly excuse me for that again. So let's have here the second one, which is the frequency polygon. So a frequency polygon is a graph constructed by using lines to join the midpoints of each interval or bin. So the heights of the points represent the frequencies. So a frequency polygon can be created from the histogram or by calculating the midpoints of the bins from the frequency distribution table. So let's see if we have an example. Okay, so this is an example of a what's that? Okay, frequency polygon. Okay, so this is an example of frequency polygon where your x-axis of the graph represents the time, and the y-axis represents the frequency. Okay, we have histogram and frequency polygon. We have also here another graphical representation is the ogive. An ogive, sometimes called a cumulative frequency polygon, is a type of frequency polygon that shows cumulative frequencies. In other words, the cumulative percents are added on the graph from left to right. Okay, so this is an example of an ogive. So your x-axis again represents the class boundaries, and your y-axis represents the frequency. Okay, so for your activity, I think you can do this on your own. So this is just to check your understanding. So here we have a class of 20 students in an English class, 30 item quiz, and the grades are as follows. This is simple. So you have to construct a frequency distribution table and construct a histogram, frequency polygon, and ogive. So this will be based on what we have discussed on how to construct a frequency distribution table. So you have to recall or go back to the part of the video where it is being discussed. Okay? So any questions with regards to our introduction? So this is just an introduction. Okay, so I think I will see you again on the next video for our next topic. Okay, bye-bye.